No. You should get that out. Okay, number 1, it says find the values of A and B. And I just want to set up the general setup one more time just to make sure everyone's clear where everything goes. Because if you don't know where things go, you're not going to know how to solve them. So you have a 45, 45, 90. You have a 30, 60, 90. Make sure on the test, you're not ever assuming an angle measure. Like, if it looks like a 30-degree angle, but I don't tell you it's a 30-degree angle, you may not assume it's a 30-degree angle, okay? If I give you the angle measure, then that's the measure we're talking about. But if it's not given, don't assume. Okay, so in the 45, 45, 90, if we're talking in terms of L, what is this side going to be? That's the L side. What is this side? Also L. That's an isosceles, right? L's are going to be the same length. The legs are going to be the same length. What's the hypotenuse? L times the square root of 2. Okay, 30, 60, 90. What is this side? What's the hypotenuse?
2L.
2L, right? We're doubling the length of the shorter leg. What's the side across from the 60? That's the L rad 3. And then across from the 30 is L. Okay? You need to know those. I don't give that to you on the test. You need to know that setup. Okay? Okay, so look at number 1 here. I'm giving you a hypotenuse in a 45, 45, 90 of 28. Does anyone remember the shortcut to the shortcut? Divide by 2, multiply by rad 2. So this is going to be 14 rad 2 and 14 rad 2. Okay? That's if you remember the shortcut to the shortcut. If you don't like the shortcut to the shortcut, then there was just the shortcut, right? This 28 is your L rad 2 side. So you can set it equal to L rad 2. And then how do you solve that? Divide by rad 2. Okay? And then we have to rationalize. You got to get the radical out of there. So we would multiply by rad 2 over rad 2. So on top, your numerator is now 28 rad 2. Your denominator, rad 2 times rad 2, is rad 4. Rad 4 is 2, right? So the square root of 4 is 2. So I get this, 28 rad 2 over 2 for my L value. That can be simplified. 28 over 2 is 14 rad 2. So you could solve it like that. You get the same answer. Anyone know the third way you could do this? What if we called both of these L and then did the Pythagorean theorem, right? L squared plus L squared equals 28 squared. That would get you there too. I'm not going to do that one right now because it's the worst option. But just know if you run out of like, I don't know what I'm doing, Pythagorean theorem will still work, okay? Any questions on that? Okay, number 2. So let's just label this as a 30, 60, 90 real quick. What side is the 32 right now in terms of L? That's your 2L. Your hypotenuse is always your 2L. Okay, your C is what? Not the value. What is it in terms of L? That's your L side. Okay, your D is L rad 3. Okay, so if I know 32 is 2L, then what is L? Yeah, divide by 2 on both sides, right? L is going to be 16 then. So that means C is 16. That's my L side. What's D? Someone whispered it. 16 rad 3. Yep, that'll be 16 times the square root of 3. Questions on that? Okay, so that's the special right triangles. Then you get to a problem like this, and it's tempting sometimes to go, oh, that looks like a 30, 60, 90. So if that's 19, I'm going to cut that in half for this one, and then it's something rad 3 for the other one. It's a 52-degree angle, right? So it's not actually a 30, 60, 90. What do you do instead? You could actually do law of sines. I wouldn't. It's more work. You're going to use sine as your trig function with SOHCAHTOA, right? Okay, so SOHCAHTOA, make sure you can spell that. It's very helpful. SOHCAHTOA. Which trig function is this? From the angle, you have the opposite and you have the hypotenuse. So that's so that's going to be the sine of what? What always comes after the trig function? The angle. So it's going to be the sine of 52 equals x over 19. And then how do you solve that? You're going to multiply by 19 on both sides. Excuse me. So type in 19 sine 52 in your calculator.
15. Oh, if you round up, it's 15.
0.0. Is that the, yes. Okay. Rounding, guys. Rounding. Let's type it in. 19 sine 52. You get this. Right? To the nearest tenth, this 7 is going to bump that up to a 0. Once that bumps up to a 0, it actually bumps the 4 up to a 5, right? So just make sure when it says round to the nearest tenth, you should be getting 15.0 for that one. Questions on that? Are you good, Joey?
Yeah.
Okay. Number 4. So this says find the value of y. What's the difference in this problem? The inverse. You're solving for an angle. If ever you are solving for an angle, law of sines, law of cosines, SOHCAHTOA, any of them, if you're solving for an angle, you must use the inverse. So it's going to be this or that, right? Inverse of whichever one it actually is. So you look at your angle and you see what two sides? What's the 5? You have the adjacent and the opposite. 5 is your opposite. 14 is your adjacent. So that's the TOA, right? That's tangent. So we're going to say the tangent of the angle equals 5 over 14. What do you plug into your calculator? Yeah, the inverse tangent, right? So you're going to go second tangent, and then 5 divided by 14. So second tan, 5 divided by 14, plug that in, and you get, this one says the nearest whole degree. What is that? 20 degrees, right? It looks like that. You would round that to 20 degrees. Any questions on anything SOHCAHTOA? Remember, solving for an angle, use the inverse. Solving for a side length, don't use the inverse. Okay, these guys. There are two formulas here. This one is the law of sines. This one is the law of cosines. I give you those on the test. So you'll see those formulas on the test. Now, what I don't give you on the test is this part. I will not tell you which one to use. So if you want to scribble those out right now, you're welcome to, but it doesn't matter if you leave it too. You're going to have to figure out which one is which. Okay. Here's my recommendation for, this is the way I do it. You can do it a different way if you want. If you want to memorize all the like SSS, SAS, which ones they work for, that's fine. I think it's easier just to try law of sines on everything first. So ask yourself, would the law of sines work here? Law of sines is always going to be the angle with a side across from it and the angle with a side across from it. So if you look at this first one, you have an angle and we're solving for the side across from it. And then you have an angle with the side across from it. So you can do the law of sines here, okay? You cannot do the law of cosines here, all right? At least not yet. So if we're going to set this up to solve to the nearest 10th, how would you set this up? What does that look like? The sign of what?
Sine 94 over A.
Sine 94 over A equals?
Sine 31
Yep.
over 21.
Yes, sine 31 over 21. Now, I will tell you right now, a lot of you on your quiz got half credit for this because you did that. Like, you set it up for me. You didn't solve it correctly. So pay attention right now. Make sure you know how to solve this because some of you did weird things and then therefore got a very different answer. Okay, so what do you do to solve this? It's a proportion. You're going to cross multiply, right? It's going to be 21 times the sine of 94. I would put the 21 out in front. You can put it behind if you finish off your parenthesis first, but it just doesn't go well a lot of the time when you do. Then go the other way. A times the sine of 31. Okay. What is your next step in solving that? Divide by what? Sine 31. We're trying to isolate the A, right? So if we divide by sine 31, this goes away. Divide by sine 31. Where do you need to put a parenthesis? After what? 94. You're going to make sure you finish off this parenthesis. If you don't, you're going to get the wrong answer, okay? So type that in. 21 sine 94 parenthesis divided by sine 31. Okay, you get 40 point, I think it said nearest 10th. Yep, 40.67436. So to the nearest 10th, that's 40.7. Okay. All right, look at this next one. You're solving for an angle. What are you going to use? The inverse, okay? We need to figure out, is it going to be sine or cosine? Law of sines or law of cosines. So you check from the angle, do I have the side opposite it? I do. Check another one. From this angle, do I have the side opposite it? I do. So that's law of sines, right? If when you have an angle with a side across from it and an angle with a side across from it, law of sines every time. Okay, so what you do is you take the sine of 47 and put it over what? 25, okay? Make sure the sine function is with the angle. I'll tell you right now what I'm going to see a lot of you do on the test is people are going to say the sine of 25 over 47. That doesn't work, okay? Always the sine of the angle and then the side across from it. So sine 47 over 25 equals sine z over 18. Okay, now we cross multiply this. So it's going to be 18 sine 47 equals, keep the 25 out in front, so 25 times the sine of z. Okay, and now here's where a lot of people mess this up on the quiz. You're saying 25 times the sine of z, okay? We're not saying 25 sine as if that's a number. 25 sine is not a number. The sine of z is a number, and 25 is a number, okay? So a lot of people tried to just divide by 25 sine right here, and you can't. You have to divide just by 25 on both sides. Don't forget this parenthesis. So you'll type in 18 sine 47 parenthesis divided by 25, and you get this number. Okay, what you're left with on the right is the sine of z. So how do we figure out what z is? What do? You got to take the inverse. So you're going to say the inverse sine of that number, 0.52657. Okay, this is the one where you could go second, sine, second, and then the negative button, and it will use that last thing that's on your screen. Please do. It's so simple that way. So second sign, second answer. And this one asked to the nearest whole degree. What do you get? 32 degrees, yep.
Wait, so you do the inverse thing and then times that long number and then you get 32?
Not times. You take the inverse of that number. Yeah, so you'll just go second. Like, if this is the number in your calculator right now, you can hit the second button and then the sign button, and that'll give you this on your calculator, right? And then if you hit second and then the negative button, it'll drop that previous answer in. Otherwise, just go second sign and then type this in.
And then why did you do the inverse? Why is it?
Because you're solving for an angle. Whenever you solve for an angle, to get that angle, you have to use the inverse.
Okay.
You're welcome. Any other questions on that one? Okay, then number 7. So again, on the test, you don't know which one you're using, law of sines or law of cosines. So I would start every one of them by checking, can I do the law of sines? So I have an angle, and I have the side across from it, but I don't have this angle, and I don't have that angle. So I cannot do the law of sines right now, which means it's going to be the law of cosines, okay? Let's set this up for law of cosines. Where do you start?
40.
Always at the angle, right? What is the angle in our formula? Here, let me copy our formula real fast. Oh, I insist on taking a funky little line there. So what is the 40 in terms of our variables? You have A, B, C, and a capital A. What's the 40?
Capital A.
That's your capital A. So this is A. What's the lowercase a?
X.
Across from the angle is the lowercase a. So that's A. And then B and C are interchangeable. It does not matter which one's B and which one's C. Okay? All right, so now we plug it in. A squared is X squared equals B squared, so 19 squared, plus 21 squared minus 2 times 19 times 21 times the cosine of what? 40, your angle.
Isn't there 21 2 times though? Because that's 2C. Oh wait, never mind. I didn't realize. Cosine and then you had a C. I thought it was 221.
Oh, yeah, no, cosine, yeah. Law of cosine has C twice, but in different places. Okay, so what do you do at this point? Plug it in. You're going to plug this into your calculator, okay? So plug in this. X squared equals, so 19 squared plus 21 squared minus 2 times 19 times 21 times the cosine of 40. And you should get this number. What's your next step?
Round to the 10.
We don't want to round yet.
Take the square root.
Square root. We want to solve for x, right? So to solve for x, we would have to square root both sides. And again, you can go second square root, second answer, and it will take the square root of that number. Or you may type that number in. There's nothing wrong with that. It just takes you longer. So second square root, second the negative button. You get x equals to the nearest 10th, 13.8. Any questions on that? Okay. Moving right along. What do you do with 8 and 9 here?
B squared plus B squared equals
Yeah, this is going to be Pythagorean Theorem. So it's really important that you put things in the right place. What is your C right now? The hypotenuse. In that first triangle, what is it?
9.
The 14, right? Across from the right angle has to be the standalone. Make sure that's always the one that's by itself. So we're going to say 9 squared plus x squared equals 14 squared. And now we can simplify that. So I'm just going to take away 9 squared from both sides. Real quick, if you do it this way, if you don't calculate 9 squared and 14 squared, plug it into your calculator just how you see it. If you go 14 minus 9 is 5 and then square it, that's wrong, okay? Let your calculator do the work or simplify first and then do the subtraction. So 14 squared minus 9 squared is 115. What's your next step? Square root, okay? Now here's the deal. When you get to this point, currently x is the square root of 115, right? If there is a perfect square that number is divisible by, you need to pull that out of it. So think of all the perfect squares. 4, 9, 16, 25, 36, 49, 64, 81, 100, okay? If any of those, if 115 is divisible by any of those, we do it. If it's not, that's your answer, the square root of 115, okay? So you go 115 divided by 64, 115 divided by 49, 115, try all those numbers if you're not sure. In this case, none of them work. So your answer is x equals the square root of 115, okay? What if your answer was the square root of 98? Can you simplify that? With what perfect square?
9.
No. How about 49 and 2? Right? What is that in simplest form? 7 rad 2. Okay, so if you can break it down, break it down. What if your answer was the square root of 100? It's 10, right? So don't forget that sometimes they just work out to perfect squares and you can take the square root of it. If you don't know, plug it in. The square root of 100, enter, it's 10, okay? So just know there's 3 different scenarios. It's a perfect square, it has a perfect square that we can simplify, or there is no perfect square and you leave it just as is, okay? Okay, so number 9, what do? What's your C? Z. That's your standalone. So it's going to be 18 squared plus 15 squared equals z squared. And then plug that in. 18 squared plus 15 squared is 549. Now what? Take the square root. Okay, so check it. Is the square root of 549 a perfect square? No, that one is not. Is there a perfect square that 549 is divisible by? What? 9. 9 works out. So if you divide by 9, I think you get 61. Is that right? So this would be 3 rad 61. Any questions on that? Okay, home stretch. We're almost there. Number 10, this one asks, if these are the sides of a triangle, is that triangle acute, obtuse, or right? Someone tell me how you determine acute, obtuse, or right. Nick, the angle, okay. How do you know with numbers like this, what?
Acute is less than like 90 or something. Obtuse is like more than 90 degrees.
That's what they are by definition, yes. How do you know, like, what are you plugging these numbers into? Pythagorean Theorem, okay? So we're going to plug it in. 15 squared plus 18 squared somehow relates to 20 squared, okay? So plug that into your calculator. 15 squared plus 18 squared is 549. Same number as the last one. 20 squared is 400. So 549 is bigger than 400. When c squared, right, here's my c squared. When c squared is smaller, what is that?
Acute.
That's acute. When the c squared is smaller, it's acute. Okay? if c squared was bigger, then it's obtuse, right? Okay, let's try this next one. 27 squared plus, 36 squared somehow relates to 45 squared. So 27 squared plus 36 squared is 2025. 45 squared is 2045. So when they're equal, what is it? That's a right triangle when a squared plus b squared equals c squared. Okay, so that would be right.
How do you know which one, like when they're there, is like A, B, C? Is it just whatever order it's in?
C is always the biggest one.
Oh, and it'll
C.
always be in that, but it'll always be like biggest to smallest, right?
Typically, not necessarily, it doesn't have to be, but you should keep your biggest one by itself.
Okay.
Yeah. Okay, try number 11. See if you can set that up. It says Zeke is standing 22 feet from the base of a tree. His eye level is 5 feet above the ground. The angle of elevation to the top of the tree is 49 degrees. What is the height of the tree? Okay, see if you can set that up for me. Draw yourself a picture, and then we'll solve it. Where's your angle of elevation? Yeah, cool.
At the guy's eyesight.
Yeah, coming from Zeke's eye, right? Looking up is his angle of elevation. So we're gonna put a 49, I didn't draw this to scale, a 49 degree angle there. Okay, his distance away is 22. That means this distance is also 22. So right now, you can solve for this top part of the tree. We'll just call that x. How do you find x? Yeah, cool.
What I did was, I saw that I did x, and I labeled it opposite, and then I did 22, and I labeled it adjacent, and then I did tan 49 equals x over 22.
Perfect. Okay, so you have the angle, right? Opposite is your x, adjacent is your 22. So that's tangent 49 equals x over 22. How do you solve for x? Multiply by 22. Yep, this goes away, multiply by 22. So you're plugging this into your calculator for x. 22 tan 49 is 25.3. How tall is the tree? What? 30.3, right. So here's the deal. He is 5 feet to his eye level. That means this right here is also 5 feet. So the tree has to be x plus that extra 5 feet. Don't forget about that 5 feet. So add 5 to it and you get 30.3 feet. Good on that? Okay, we pretty much just took your test. This is what it looks like. Those are the questions with different numbers and slightly different setups, but the same basic ideas. If there's anything from that you're not sure about, talk to me today, come tomorrow morning and go over whatever you need to go over tomorrow morning. We want to make sure we got it, okay? Yeah. You're turning it in, yeah. It's free 5 points, right? Why not turn it in? Okay, go ahead and submit that right now. I will hand out your quizzes while you are submitting, and we'll go over those if you have any questions. Come on up when I call your name. All right, let's talk through this quiz. That first one, right, that's a 45, 45, 90. So you have L, L, and L rad 2 for your setup. So if our L side is 4, then what is A? 4, right? Your legs are always the same. So 4, 4, and then what's B? 4 times the square root of 2. Okay, so it's L rad 2. What's C on number 2? This is your L side, right? This is your 2L side. So if 16 equals 2L, then all you're doing is dividing by 2. So your L, or your C, will be 8. So what's D? That should be 8 rad 3, right? So L rad 3, 2L. All right, number 3, from the angle, you have the adjacent and the hypotenuse. So that's cosine of 37 equals x over 17. So you multiply by 17 on both sides and you get 13.6.
On that, like the one above that, how do you know which one is, like, I know which one's like hypotenuse, but how do you know which one is like the leg and like the leg?
So the leg is the shorter side, and the leg times something, leg times rad 3 is going to be longer,
Okay.
right?
Sometimes they look really close. I'm not sure which one.
In a 30, 60, 90, they shouldn't ever be close, yeah. Because the 30, 60, 90 is always going to be significantly longer here than it is here. So this side will be the longer side. You can always figure it out from where the angle is. So across from the 30 is L. Across from the 60 is always L rad 3. Okay. Okay, number 4. So this one, you have from the angle, the opposite and the adjacent. So that's tan y equals 5 over 12. And then you're solving for an angle, so you got to use the inverse. So you plug this in, inverse tan of 5 over 12, and that came out to 23 degrees. 5 and 6 were both law of sines, and you have from the angle, the side across from it, from the angle, the side across from it, right? A lot of you got to this point, but then just didn't solve it right. That's what I was talking about on the practice quiz a few minutes ago, right? Make sure you're cross multiplying. Put this parenthesis in, so you're going to divide by sine 39 on both sides. 18 sine 94 parenthesis divided by sine 39. And that's 28.5. And then number 6 is very similar, still law of sines, but you're solving for the angle, so you have to do the inverse. So it's going to be the sine of z over 18, that's here, equals the sine of 71 over 25, that's here. And then cross multiply that, so you get this, okay? 25 sine z equals 18 sine 71. Then divide on both sides by 25, and then you'll get this. So now the sine of z equals that, so you take the inverse sine of 0.6808, and that comes out to 43. And then these last two, that is Pythagorean Theorem. 30 squared plus 40 squared should equal x squared. This one works out beautifully. 30 squared plus 40 squared is 2,500. 2,500 is a perfect square, so that's 50. Number 8, some of you mixed up where you put your x. It's not the x that is by itself. It's the hypotenuse that's by itself. So 8 has to be your standalone here. So if we take away 5 squared and take away 5 squared, you get 39. And then we take the square root of that. That doesn't have a perfect square. So it's just the square root of 39 for that. Any other questions? Okay. If you want to see answers to the homework, I will put those up right now. And then if we